12 hours. 10 guns, 1 wood on the Somme. On the 24th of August, 1916, the crews of the 100th Machine Gun Company fired without stopping until the barrels glowed and the water jackets boiled dry. By the time the order came to cease, records suggest close to 1 million rounds had passed through those 10 guns. Guns combined. Not one gun was withdrawn from action. Not one gun failed to fire. Barrels were swapped. Water was refilled from shell holes, from puddles, from anything that could be carried forward under fire. The guns themselves never stopped. 52 years later, the British Army retired that same design. Not because it had broken, but because nothing about it had ever needed to change. That is not a story about a machine that worked. It is the story of a weapon so mechanically honest that the only thing that could end its career was time itself. Hiram Stevens Maxim was born in a farmhouse near Sangerville, Maine, in February 1840, in a district whose economy ran on timber, water-powered sawmills, and the kind of self-taught mechanical ingenuity that isolation demanded. His father worked a mill and a small farm. There was no formal engineering education waiting for the son, only an early, restless talent for machines, first applied to mousetraps and locks before it found anything resembling a career. By his 20s, Maxim was working as a draftsman and mechanic in factories across New England, then in New York, filing patents on everything from hair-curling irons to gas lighting systems. Records suggest he held over 100 patents before he ever built a firearm. The craft that mattered here was not gunsmithing at all. It was precision mechanical engineering, the discipline of designing parts that had to move against each other thousands of times without failing, under stress, under heat, under load. That background, and not any inherited gun trade lineage, is what made the Maxim gun possible. In 1881, Maxim relocated to London, reportedly on the advice of an acquaintance who told him, "If you want to make a fortune, invent something that will let Europeans kill each other more efficiently." The line is often repeated in company histories of the period. Whether or not Maxim heard it in those exact words, it captures the commercial logic he acted on. The market gap. Part A. Every rapid-fire weapon then in military service depended on the operator. The Gatling gun required a soldier to turn a hand crank, chamber by chamber, barrel by barrel. Rate of fire was limited by human arm strength and fatigue. Every existing design also required multiple barrels, heavy, expensive, mechanically complex, to avoid a single barrel overheating under sustained use. Part B. Maxim, studying the recoil of a rifle as a younger man, had felt the specific physical kick against his shoulder and reportedly told colleagues that the energy wasting itself against the shooter could instead be captured and put to work. Not a eureka moment. An engineer's direct physical observation translated into a mechanical proposition: let the gun load, fire, extract, and reload itself, powered entirely by its own recoil. By 1884, working from a small workshop at Hatton Garden in London, Maxim had built a working prototype. Records suggest the initial development cost ran to several £1,000s, largely self-financed from his American patent income. The gun fired from a fabric belt of cartridges, recoil-operated, capable of sustained automatic fire from a single barrel cooled by a water jacket. A steel sleeve surrounding the barrel, filled with water, that absorbed and dissipated the heat of continuous firing that would otherwise warp or burst an air-cooled barrel within seconds. In 1888, the Maxim Gun Company merged with the Nordenfeldt Guns and Ammunition Company. In 1897, that firm merged again with Vickers, Sons and Company, the Sheffield steelmaker turned armaments manufacturer, whose works stood on the Thames at Erith in Kent. The new company took the name Vickers, Sons and Maxim. That merger, a steel manufacturer's production capacity married to Maxim's mechanism, is where the machine gun that would fight 2 world wars actually began to take shape. The weapon that made Vickers a household name in British ordnance was not technically Maxim's original design at all. It was a redesign, and the redesign is the real story. Vickers' own engineering department, working through the early 1900s, took Maxim's toggle lock mechanism, a hinged, elbow-like locking arm that straightened under the force of the round firing, sealing the breech shut, then folded again under recoil to eject the spent case and chamber a new one, functioning much like a human knee locking straight to bear weight, then bending to release it, and inverted it. Where Maxim's toggle folded upward, the Vickers toggle folded downward, beneath the breech rather than above it. That single change did something the British Army had been asking for without quite knowing how to get it. It lowered the profile of the receiver and, combined with the use of high-tensile steel in place of the bronze and iron of the original Maxim gun, cut the weapon's weight by roughly a third, from around 60 pounds down to approximately 40 pounds for the gun itself, excluding tripod, water, and ammunition. Officially adopted by the British Army in November 1912 as the Vickers Machine Gun, .303-inch Mark I, it fired the standard .303 British rifle cartridge, the same round issued to every infantryman carrying a Lee Enfield. From a 250-round fabric belt, at a sustained rate of approximately 450 to 500 rounds per minute, recoil-operated and water-cooled exactly as Maxim had conceived it. The price told its own story. A Vickers gun, complete with tripod, cost the War Office roughly £175 in the years immediately before the First World War, at a time when a British Army private earned around £1 a day. Less than £20 a year, the gun cost the government the equivalent of nearly a decade of a private soldier's pay. It was not a weapon built to be cheap. It was a weapon built to never need replacing. Go to market, for a company like Vickers, meant one customer above all others, the War Office itself, supplemented by export orders to Commonwealth dominions and to foreign governments seeking a proven design under license or direct purchase. The patent moat here was not a single patent at all. Maxim's core recoil-operated patents were aging by 1912, but something arguably stronger, an official Army specification written in practice around the Vickers gun's exact characteristics, combined with a manufacturing relationship between Vickers and the War Office that newer, unproven designs struggled to break into. The reputation the gun earned in its first years of service became, itself, the barrier to entry. The trust was not paperwork. It was the moat. Early institutional buyers, named specifically the British Army's Machine Gun Corps. Formed in October 1915 once the scale of the weapon's demand became clear. The armies of Australia, Canada, and New Zealand, each purchasing Vickers guns for their own expeditionary forces. The Portuguese Army, and the Imperial Russian Army, which purchased Vickers pattern guns before 1917 through direct contract with the Erith Works. By 1915, the Erith factory was producing several hundred guns a month, a figure that would climb sharply as the demands of trench warfare made clear exactly what kind of weapon the British Army had, almost by accident, gotten exactly right. By 1916, the Vickers gun was no longer simply British Army equipment. It was the spine of an entirely new branch of service. The Machine Gun Corps. Formed in October 1915 and equipped almost exclusively with the Vickers, grew to over 170,000 men who passed through its ranks by the end of the war. Organized into companies, then battalions dedicated entirely to sustained, coordinated machine gun fire, a discipline that had not existed in the British Army a decade earlier. The Australian Imperial Force fielded Vickers guns at Gallipoli in 1915, then across the Western Front. The Canadian Corps carried them into Vimy Ridge in April 1917, the first Canadian-led offensive of the war. The Portuguese Expeditionary Corps carried Vickers guns into the Battle of the Lys in April 1918. The New Zealand Division carried them through Passchendaele, each force training on the same gun, maintaining the same manuals, dependent on the same water-cooling discipline that kept a barrel firing for hours rather than seconds. By 1917, Vickers Erith Works and its associated production lines were turning out several thousand guns a year, supplemented by additional manufacture under license and by government-sponsored production at other British engineering firms. Once the scale of demand outstripped any single factory's capacity. The wartime segment. On the 4th of August, 1914, Britain declared war on Germany. Within weeks, the War Office placed emergency orders for Vickers guns at a scale the Erith Works had never previously produced, with delivery schedules compressed from the leisurely peacetime pace of pre-1914 procurement to something closer to continuous, round-the-clock manufacture. Before the war, Vickers had built machine guns as one specialized product among many. The company also manufactured artillery, warships, and armor plate. The war reordered those priorities entirely. Machine gun production, along with shells and small arms, became the measure by which the factory's contribution to the national effort was judged. Women entered the Erith Works in numbers that would have been unthinkable in 1913, trained on precision lathes and inspection gauges to machine components to the tolerances the Vickers action demanded. Tolerances tight enough that a poorly fitted lock could jam a gun mid-belt at exactly the moment a jam could not be afforded. Skilled male machinists who had spent decades on the factory floor left for the front in the war's first year. Much of what they knew about fitting a Vickers action by feel, rather than by gauge alone, did not fully return with them. The stakes sentence. If the water jacket on a Vickers gun was pierced by shrapnel during a German counterattack and the crew had no water left to refill it, the barrel would overheat within minutes, the gun would fall silent, and the section of trench it had been covering would have no answer to an advancing infantry assault. The confirmed deployment scene returns to where this story began. On the 24th of August, 1916, during the Battle of the Somme, 10 Vickers guns of the 100th Machine Gun Company were tasked with firing a sustained indirect barrage over high wood in support of an infantry assault for a duration that would stretch to 12 hours. The crews fired in relays. Barrels were changed as they overheated. Water was carried forward under fire when the jackets ran dry, refilled from shell craters when nothing else was available. Records suggest that combined, the 10 guns fired close to 1 million rounds before the action ended. Not one gun withdrawn, not one gun failing under the strain the design had been built specifically to survive. The action became, within the machine gun corps and beyond it, the standard reference for what sustained fire actually meant, and what a well-maintained Vickers gun could be asked to do without breaking. The gun's reputation earned it formal recognition beyond the battlefield report. The Machine Gun Corps' official history, compiled after the war, singled out the Vickers' reliability as a defining factor in the Corps' operational doctrine, a weapon whose failure rate in sustained fire had become, by 1918, almost a footnote rather than a planning concern. Innovation did not stop with the original Mark I. The Mark I asterisk incorporated minor production refinements through the war years. The 1918 tripod modifications improved indirect fire accuracy for the barrage role the gun had proven so effective in at high wood and elsewhere. Between the wars, the gun was adapted for aircraft use as the Vickers Class C and Class E, air-cooled variants stripped of the water jacket for fighter armament, and for tank mounting and early armored vehicles. The same recoil-operated mechanism proving adaptable well beyond its original infantry role. Maxim himself, knighted in 1901 for services to British industry, lived to see his mechanism become the foundation of an entire branch of the army before his death in 1916, the same year as High Wood, though records do not indicate he lived to hear of that specific action. By then, the gun's development had long since passed from his hands into those of Vickers' own engineering department and the generations of Machine Gun Corps officers who refined its tactical doctrine. What was preserved was the mechanism itself, essentially unchanged. What was already beginning to shift was the Army's sense of what modern infantry combat would demand next, and whether a 40-pound, water-cooled, crew-served gun could remain at the center of it forever. The turning point for the Vickers gun was not a battlefield failure, it was a doctrine. By the interwar years, military planners across Europe had begun rethinking what infantry firepower should look like. The static, trench-bound warfare that had made a 40-pound, water-cooled, crew-served gun the correct tool for the job was no longer the war anyone expected to fight next. Mobility, the ability for infantry to advance carrying their own automatic firepower, rather than setting up a fixed position behind a tripod and a water can, became the new specification. Germany's development of the MG-34 and MG-42 in the 1930s demonstrated the alternative. Air-cooled, quick-change barrel, portable by a 2- or 3-man team without a water supply at all. Britain's own answer, developed in parallel, was the Bren gun. Light, magazine-fed, carried and fired by a single soldier on the move. Under pressure, through the 1920s and 1930s, the Vickers gun received no fundamental redesign. No move to air cooling, no reduction in weight, no replacement of the fabric belt with a disintegrating metal link. The War Office's response to changing doctrine was not to modernize the Vickers, it was to develop different weapons alongside it, and to relegate the Vickers, gradually, to a specialized, sustained fire support role rather than the Army's primary automatic weapon. That relegation, and not any single procurement decision, was the structural threat. A slow narrowing of the gun's job description, year by year, while newer designs took over the roles the Vickers had once filled alone. And yet the gun did not disappear. It fought through the Second World War in exactly the sustained fire support role it had been narrowed into, with British and Commonwealth machine gun battalions still relying on the Vickers for indirect barrage fire in North Africa, in Italy, in Northwest Europe, its water-cooled endurance still unmatched by anything lighter. It went on to serve through the Korean War in the early 1950s, still in Commonwealth service, still performing precisely as it had at High Wood nearly 4 decades earlier. The structural force that finally ended the Vickers gun's career was not foreign competition, and it was not financial collapse. It was a NATO-wide procurement shift, the general-purpose machine gun concept, a single air-cooled weapon capable of both the light, mobile role and the sustained support role that had previously required 2 entirely separate categories of gun. Belgium's F.N. Herstal developed the MAG general-purpose machine gun in the 1950s. Britain adopted it under license in 1966 as the L7A1, entering full service by 1968. A single air-cooled, belt-fed weapon, light enough to be carried and fired by an infantry section, yet capable, with a tripod and sustained fire kit, of the same indirect barrage role the Vickers had defined at High Wood. The Vickers gun was not defeated by unreliability. It was defeated by arithmetic. One weapon, adopted across NATO, doing the job that had previously required a Bren gun for mobility and a Vickers for endurance. There was no longer a specification the Vickers alone could satisfy. The last Vickers guns were withdrawn from British Army first-line service by 1968, some seeing continued reserve and training use into the following years. 56 years of continuous frontline service, a span matched by almost no other automatic weapon in any army's history. Closed not with a failure report, but with a specification document naming a different gun. The Vickers, works at Erith and Crayford, by then absorbed into the wider Vickers-Armstrongs industrial group, had long since diversified into aircraft, shipbuilding, and heavy engineering. Small arms production had become a minor line within a much larger company. There was no single factory closure to mark the Vickers gun's end. No mass redundancy notice, no bankruptcy filing. The contract simply was not renewed. The tripods were stored or sold as surplus or scrapped. The water cans were emptied for the last time. The machine gun corps itself had already been disbanded. In 1922, its role folded back into the infantry it once stood apart from. The gun that never stopped firing was retired by a document, not by a defeat. There was no brand resurrection for the Vickers gun, and no attempt at one. Unlike a commercial firearm whose name might be revived by a licensing deal, or a retro production run, the Vickers Machine Gun was a government specification weapon built by an industrial conglomerate that had long since moved on to aircraft, warships, and heavy engineering. When the contract ended, the name simply stopped appearing on new production. Some names do not survive. The silence here is part of the story. What survives is the object itself and the collector interest around it. Deactivated Vickers guns, tripods, and water cans surface periodically at UK arms, fairs, and at auction houses handling military ordnance, drawing serious interest from collectors of Machine Gun Corps history specifically. The Imperial War Museum holds Vickers guns in its collection, including examples on public display connected to its Somme and First World War galleries. The Royal Armouries, at Leeds and at Fort Nelson, holds Vickers guns among its reference collections of British service automatic weapons. Regimental museums connected to Machine Gun Corps successor units maintain examples with unit-specific provenance, some traceable to named actions. Why does the original still matter when the L701G PMG replaced it over half a century ago? Because the Vickers gun remains, among historians and reenactment groups researching the Machine Gun Corps, the only way to physically demonstrate what sustained indirect barrage fire, the specific tactical role invented at places like High Wood, actually required. The water, the barrel changes, the belt loading rhythm of a 3- or 4-man pool, 4-man crew working in relay for hours. A GPMG cannot demonstrate that history. It was built to make that history unnecessary. The Erith Works itself no longer exists as an arms factory. The Vickers site on the Thames passed through successive industrial ownership after the Second World War, before large sections of the riverside land were redeveloped for housing and light industry in the later 20th century. Little at the site today marks what was, for over half a century, one of the most productive machine gun factories in the world. The surprise footnote belongs, fittingly, to Hiram Maxim's family rather than to Vickers itself. Maxim's younger brother, Hudson Maxim, became a pioneer of smokeless propellant and high explosives in the United States, his own inventions feeding directly into American naval ordnance for decades. Two brothers on opposite sides of the Atlantic, each reshaping how their adopted nations made war, largely independent of one another. What the Vickers gun represents, finally, is not a story about a single brilliant weapon. It is a story about what happens when a mechanism is engineered correctly the first time, and then simply left alone to do its job for 56 years while the world around it changed doctrine, weight limits, and tactics 3 or 4 times over. The Machine Gun Corps, that built an entire identity around this weapon, disbanded decades before the gun itself was retired. Military procurement, unlike engineering, rarely rewards a design for outliving its original justification. It rewards the design that fits the next specification. The Vickers gun did not fail that test. It simply belonged to a category of warfare that eventually stopped being fought. Today, in the hands of collectors and museum armorers with the correct deactivation certification, surviving Vickers guns can still be traversed on their tripods, their water jackets still filled for demonstration, the toggle lock still folding and straightening exactly as Vickers engineers redesigned it in the years before 1912. Still doing on a quiet range in Kent or at a regimental museum open day. Precisely what it did over High Wood for 12 unbroken hours in August 1916. The gun that never stopped firing has, at last, stopped. But it never once failed to. Next time, we follow another British weapon built for endurance rather than speed. One that traded the Vickers water jacket for something lighter and paid its own price for it. See you in the next one.